Hello everyone. So today we are going to talk about rate of change, which is also sometimes called slope. So what I want you guys to do is take time to copy this part of the notes down right now. Copy just that part while I'm talking, and you can pause the video if you need more time. Okay? So slope basically measures the steepness of a line to visualize how a value changes in relation to another. So the values we're going to talk about is it's going to show us how does the x value change and the y value change. Do they both get more positive? Do they both become more negative? Does one become positive and one become negative? It's going to help us see that. And because we're looking at change, slope is also sometimes called rate of change. Okay? And this word right here, steepness, if you don't know what that means, for example, let's say we have a mountain, all right? If this is a mountain, how steep it is will tell me if it's harder or easier to climb. A super, super steep mountain looks like that. It's really, really hard to climb. But a less steep mountain may look like this. It's easier to climb. So that's what the word steepness means. Okay? So again, if you have not copied this down, go ahead and pause the video and copy it, and then we're going to go to the next part. So hopefully you're done copying, because now we're going to look at the different types of slope. So we have positive slope. So positive slope means you have a line that goes upwards in this direction. That's a positive slope. So if you think about this like a mountain, don't draw the rest of this. If you think about this like a mountain, if I go up the mountain, that's a positive slope. Okay? Next we have a negative slope, which is the opposite. It's going down. So if again I'm thinking about a mountain, this looks like I'm going down the mountain. It's a negative slope. Zero slope means there's no hill to it. It's flat, right? It's so easy to climb because it's completely flat. So a zero slope just looks like a straight line across. And an undefined slope looks like this. If I were trying to climb a mountain, I could not climb this directly upwards without any help, right? I would fall. Imagine someone trying to climb this, right? They would just fall down. So this is an undefined slope. And if it helps you, you are totally welcome to draw your people climbing up the mountain and down the mountain and flat on the mountain and there. If that helps you see it, you are welcome to draw those. All right, let's draw the next part. Let's write the next part. So now we're going to figure out how can I calculate the value of slope from a table, from a graph, or when somebody gives me 2 points. So pause the video right now and copy down this part of your notes. Hopefully you are done copying, so let's look at how to calculate slope from these 3 ways, all right? So let's look at our table. So the formula for slope is the change in y. That's what that triangle means. That triangle means change. So if you want to write that down, we can do that. The change in y over the change in x. So again, we need to figure out how does y change? And at the same time, how is x changing? So let's look at our table. The change in y, we're looking at when I jump from this number to this number, what is my change? And if I look at it, the change from 0 to 2 is 2. I'm adding 2. So my change in y is 2. And then when I'm trying to figure out my change in x, from 0 to 1, my change in x is just 1. So my slope is 2 over 1. Every time y increases by 2, x is only increasing by 1. And I can simplify this fraction to just the number 2, because whenever I have a denominator of 1, I can simplify that. When I look at a graph, it's the same thing. We just call it something else. We call it rise over run. It's the same thing though, because look at what I'm about to do. Let's pretend I have 2 points. I want to focus on these 2 points right here in green. Rise means how far up or down am I moving? So to get from the first dot to the second dot, how far up do I have to go? And if you guys look, I have to go about 2 spots up. And I think I drew my dots incorrectly, so you guys can fix your dots if you want to. My dots should have been here and there. Okay? So I'm going up 2. And up is on the y-axis. So the change in y, or the rise, is 2. So I'm going to write the word rise. And my rise is 2. My run means how far over do I have to go? And when I count, I only go over 1 box to get to this second point. I'm only going over 1. So my rise is 2 and my run is 1. So same thing as the other part, right? And I know when I have a denominator of 1, I can just eliminate it. So my slope for my graph is 2 over 1. And it's always going to be 2 over 1. If I picked a different point, like let's say I picked, let me draw my points back. Sorry, guys. If I had picked, let's say, this point and this point, my rise, or my change in y, is still 2, and my run, which is my change in x, is still 1. It's always going to be the same, no matter where I am on the line. And then finally is my last one. Let's pretend I'm giving you 2 points, but I don't tell you or give you a graph to look at. We have to calculate slope this way. So we know that for every point, we have an x coordinate and a y coordinate, right? Same thing here. I have an x coordinate and a y coordinate. And just to kind of organize myself, since this is the first point, I'm going to call this x1 and y1. And since the other one is my second point, I'm going to call this x2 and y2. So if you look, x1 is the value 1, x2 is the value 2, y1 is the value 2, and y2 is the value of 4. So now I'm going to input those values into my formula, which again is the same exact thing. When I'm looking at the difference between my y's, that's a change in y, right? And when I look at the difference between my x's, it's a change in x. So all of these things are the same, and all of these things are the same. We're just talking about it in different ways. So again, if I have my formula, y2 minus y1 over x2 minus x1, and I look at my points, y2 is the number 4. So I'm going to put 4 minus, y1 is the number 2, and then x2 is also the number 2, minus x1 is the number 1. And if I subtract them, 4 minus 2 equals 2, and 2 minus 1 equals 1. And I can simplify that to the value of 2. So now we were all able to find slope 3 different ways. We found slope 3 different ways. Okay? And the last way we did not talk about was from an equation. Okay? So the last point we did not talk about is finding slope from an equation. Okay? And we will talk about how to find that on the next page. So right here, we're just going to write a note to ourselves. Look on next page, because we're going to do notes on that another time. Okay, so the last thing I want you guys to do is give me a quick summary of the notes that we took today. What did we learn from these notes? And we're definitely going to practice, because we're going to need to have some practice doing these 3 slopes. So your note should look like this. Okay, and we are all done.